everybody, it's Steve with Fun here, and I'm at the Greater Boston District event. I'm here with Team 78 Airstrike, who have a really cool robot. You guys are sitting like 12 in the rankings right now, but I definitely think that's going to go up. So they got some really, really cool automation here with their robot and an awesome powder-coated look. So let's just go down the line, everybody, quickly say your names, and then we'll jump right into the robot.
I'm Andrew.
I'm Landon.
I'm Noel.
Cameron.
I'm Haley.
Cool. Let's jump right in, guys, because there's a lot to talk about with this robot.
This video on Fun is brought to you by our viewers, supporters, members, and also in partnership with the following. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions. Osh Cut is the premier metal cutting service for first teams. No minimum order, options for same-day turnaround, 3D tube laser cutting, and with nearly 500 variations of metal in stock and ready to cut. Just upload a file and claim your 50% off discount when you scan the QR code or go to funroboticsnetwork.com/OSHCUT.
I'm going to explain some of the basic superstructure. The main thing about our robot is we have this tilting continuous elevator. We have the motors here that control the pivot, which allow the elevator to tip up and down. And then we have another set of motors to control the extension of the elevator. And because it's continuous, all of the segments extend at the same time. It's a bit heavy. Yeah, it's a bit heavy.
And then what's this cording here that you guys are using? Is it anything special?
It's Dyneema, which has very low stretch. So it's perfect for elevator stabilization and control.
Very cool.
And then another thing I want to talk about is the wrist here, which controls the intake. We have a gearbox here with roughly 151 gear ratio. It's fed up into this gear here, which can rotate the wrist into multiple different positions. We have about 180 degrees of freedom, and we can do it about 0.5 seconds.
Awesome. Who's next? Go right ahead.
So I'm going to be talking about the intake. We have this combined coral and algae intake, all powered by one motor. We're using polycarbonate tubes covered in cat tongue tape, which is sort of grip tape. It allows us when we spin one way to hold the algae here, and the other way to hold the coral in here. The reverse outtakes.
Okay. And I'm assuming this is your regular cat's tongue for grip?
Yeah, it's just cat tongue tape.
Cool.
We're also using this polycord here that reverses the direction.
Nice. It is interesting. I'm not seeing a lot of these super wide intakes this year. A lot of people went for like a real tight point loading on the bot, but I think you guys are going to be telling us a little bit later about why you guys did that, right?
Yeah, our main reason for doing that was that we wanted to be able to get coral from multiple different spots along the coral station, so in case our alignment was a little bit off, it would still go in. We have this can range sensor, which
cool. All right. What do you guys got next?
So as Cam had mentioned, our intake is pretty wide and it's responsible for taking in and putting out the coral. And since it's so wide, the coral can be put into any area, and we need to know where that is so it can accurately align itself with the reef so we can score properly. And what we have here is a can range sensor, it measures distance, so we can find where the coral is actually positioned in here so we can place it on the reef accurately.
Okay, and that's a new product this year from CTRE, right?
Yes.
Very cool. So that it's a distance sensor, right? Like time of flight sensor?
Yep.
Very cool, very cool. And that just sits on your can chain. You're not worried about running wiring all the way back to the reel and all that?
Nope.
Great.
So what Landon was talking about there was using the can range to measure the distance at which the coral was relative to the center of the intake. And what we use that for is we have a lot of driver automation this year with our robot. As you can see here, we have 3 different AprilTag cameras, which are measuring the distance and relative position to AprilTags on the field. And we fuse all of those into one common position that the robot thinks it's in. and then we can use that to run various PID control loops and pathfinding commands to drive our robot autonomously around the field, even during teleop. So, for example, when we're scoring into the reef, we have a button on the drive controller which automatically centers the robot and aligns it into the best optimal position to score into any level of the reef. So the two cameras here are cross-eyed to see the AprilTag that is very close up to the robot on the reef wall, and we get a very clean estimation of the robot's position. However, we do have the coral which can be at a variable distance along the intake. So that's what we use the sensor for, to know where it is exactly, and then we will offset the alignment of the robot to the reef by that distance offset of the coral from the center of the robot. So that way we can ensure that we always have a consistent scoring accuracy. We did measure the diameter of the branch pipes to the inner diameter of the coral. Is about 4 centimeters of error that we can have within our alignment and the reef. So we really did have to make sure that all of our both estimations were very tight and very accurate.
Awesome.
Furthermore, we have some more advanced alignments. We do use PID loops to move our robot, but we have also line segments defined on the field, which denotes the boundaries such as the human player intake stations on the barge. So when the driver presses button to align to those points of interest, it finds the closest point along that line and then uses a signed distance field to calculate the position of that closest point and then drive to an offset from that to ensure that we have the fastest, closest, least travel distance to have the shortest cycle times while remaining fully autonomous and continuous along any point of interest.
So just a quick question with that. So when you guys are driving up, how does your driver tell the robot, do you guys just basically say, hey, I want to go score there, and the robot does it from there, or you guys still have a bit more manual control over it?
I guess it's more of a combination, more between the two. The driver has control over any function related to the driving, so the driver can drive normal field-oriented swerve control, but then, as I said, we have buttons for aligning to every point of interest.
Okay.
So one left bumper would be aligned to left branch, the closest left branch.
Okay.
Right bumper would be closest right branch. And then once we get there, it is up to the manipulator to move the mechanisms. And again, there are also button presses, and it moves the entire mechanism to a preset, which is then activated to score by another trigger press.
Cool. All right, what's next?
So aside from just the powder coating looking really aesthetically pleasing, it also serves a purpose. So on our base here, we have white powder coating to help see things that fall down to the bottom of the robot more easily.
That is one of the cleanest electronics pans I've ever seen.
Yeah, so we did a lot of purposeful wiring here. As you can see, there's wiring actually being fed through this tube and the tube over here with grommet holes. And we also have an E-chain that helps support the elevator going up and down more smoothly. Sure.
All right, you guys want to turn it on quickly and just run us through all your scoring positions so we can see the spot in action?
So here's our coral intake position from the human player coral station. There is our L1 scoring position. Here we have our algae intake position. Sorry? Oh, this is REEFSCAPE, that's L2 scoring position. Then we have L3. And finally L4.
Then for algae, we have our L2 algae intake position. This is our L3 algae intake position. That's our ground algae intake position. And then this is our net position here.
All right, guys, that looks awesome. I mean, I already saw it in competition and a couple matches back, and you guys are looking like you're set up to be easily one of the top teams at this event and probably in the district. So you guys are here this week. Where's your next event?
We are going to be at URA.
Okay,
Yeah.
so that's a week 3 event.
Yes.
All right, we'll see you there. Well, good luck for the rest of this competition, and I'll see you guys next week at URI.
Yeah.
All right, awesome.
Great.
Thanks,
Thank
guys.
you so much. Appreciate it.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Osh Cut is the premier metal cutting service for first teams. No minimum order, options for same-day turnaround, 3D tube laser cutting, and with nearly 500 variations of metal in stock and ready to cut. Just upload a file and claim your 50% off discount when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions.